Welcome back to Class 6 series on my channel Mathify with Minakshi. What do you think happens when we start adding odd numbers one by one? And what about when we add counting numbers up and down? Have you ever observed a pattern there? Something interesting happens. We can actually arrange the dots in a square grid and split them neatly in these two ways. Isn't that amazing how numbers form such beautiful patterns? So let's see pictorial representation of square in these two ways. First, when you will add first n odd consecutive numbers, what you will get? Adding first n odd consecutive numbers. So let's see what we'll get. If you'll add first odd number, that's only 1. If you will add first two odd numbers, that is 1 plus 3, you will get 4. And what is 4? It's 2 square. If you will add first three odd numbers, that is 1 plus 3 plus 5, you will get 9, and that is 3 square. If you will add first four odd numbers, 1 plus 3 plus 5 plus 7, you will get 16, and that's 4 square. If you will add first five odd numbers, 1 plus 3 plus 5 plus 7 plus 9, you will get 25, and that's 5 square. If you will add first six odd numbers, 1 plus 3 plus 5 plus 7 plus 9 plus 11, you will get 36, and that's 6 square. So from here we can say that whenever you will add first n odd consecutive numbers, you will always get square of that number, that is n square. Now let's see how we can represent this in picture form. So here I have given you one square, and if you will see carefully, this is 6 square, that is 36. How I can represent this as sum of first six odd numbers? So see carefully, this is 1, then here we have three circles, we can say 3, then we have 5 circles, we can say 5, then we have 7 circles, we can say 7, then we have 9 circles, we can say 9, and at last we are remaining with 11 circles. So that means we have divided 36 as sum of first six odd numbers. So this is the pictorial representation of this way. Now let's move to second way, that is adding counting numbers up. So I'm writing till where you will go, till n, and then down. And down you will always go till 1. So first you should know what is counting numbers. That is 1, 2, 3, 4, 5, 6, and so on. Now what is the meaning of counting up? When we say counting up, that means in first step you will say 1, then in second step you will say 1 plus 2. In third step you will say 1 plus 2 plus 3. In fourth step you will say 1 plus 2 plus 3 plus 4. So that's the meaning of counting up. But here we have to do counting up and down. So what is the meaning of counting up and down? That in first step you will go till first. In second step, first you will go up till 2, and then you will come back to 1. In third step, first you will go till 3, 1 plus 2 plus 3, and then you will stop, and then again you will come down to 1, that is plus 2 plus 1. In fourth step, you will write 1 plus 2 plus 3 plus 4, then you will stop, and then you will come back plus 3 plus 2 plus 1. In fifth step, 1 plus 2 plus 3 plus 4 plus 5, then you have to stop, that is counting up till 5, then you will come back 4 plus 3 plus 2 plus 1. In sixth step, you will say 1 plus 2 plus 3 plus 4 plus 5 plus 6, that is counting up. Now down, 5 plus 4 plus 3 plus 2 plus 1. Now did you notice something here? Now you will see that here we'll add the counting numbers till what number, and that's the answer n square. Here we go till 2, so answer is 2 square. Here we counting up till 3, so that means 3 square. Here we count up till 4, that's why 4 square. And here we count up till 5, and that's why 5 square. And in last step we count up till 6, and that's why is 6 square, that is 36. So you have to see the number carefully, that adding counting numbers up till what number? Because that's your answer. It will give you square of that number. So here, if you will see carefully, it's 6 square. That is 36. So how we can write 36? 1 plus 2 plus 3 plus 4 plus 5 plus 6. First, you will go till 6 and then you will come back to 1. 5 plus 4 plus 3 plus 2 plus 1. So how I can represent this in picture form? You will say 1 plus 2 plus 3 plus 4 plus 5 plus 6, and this is your central line. It's also known as central line, where we have 6, then 5, then 4, then 3, then 2, and then 1. So central line, you have to always see in central line we have 6 circles, and that's why this represents 6 square, that is 36. So these are the two ways in which we can represent a square. Now let's move to figure it out. That's on page number 8. Question number 1. Can you find a similar pictorial explanation for why adding counting numbers up and down will give you square numbers? Just see carefully. First is 1, then 1 plus 2, and then plus 1. That means first you will go till 2 and then down till 1. Here adding up till 3 and then down till 1. So you have to always see the highest number. So in first you will simply say it's 1 square. Then we are going till 2. So you will represent 2 square. That's 4. Now how we can represent this pictorially? So I can say this 1 plus 2 plus 1. 1. Then here we have 2 and then here we have 1. So 1 plus 2 plus 1. This is 2 square. You can say 4. Then we have highest number as 3. 1, 2, 3. 1, 2, 3, and then 1, 2, 3. It's 3 square, that's 9. Now how I can represent that as counting up and down? 1 plus 2 plus 3 plus 2 plus 1. So this represents your square numbers. Let's move to question number 2. By imagining a larger version of your picture or drawing it partially as needed, can you see what will be the value of 1 plus 2 plus 3 up to 99, then 199, and then up to 1? So as I told you that you have to always see whenever it's counting up till 100 and then down till 1, you have to always see the highest number. Here the highest number is 100. So you can say that answer will be 100 square, and that is 10,000. So what we have used in question number 2? We have used second way, that adding counting numbers up till n and then down to 1 always give n square. So here in our question we are adding up till 100, and that's why our answer is 100 square, that's 10,000. Let's move to next question. Question 3. Which sequence do you get when you start to add all one sequence up? First, you should know what is all one sequence. That is 1, 1, 1, 1, 1, and so on. So, adding one's sequence up, what you will get? You will get, what's the meaning of adding up? In first step, you will write only 1. Then in next step, you will add 1 and 1. In next step, you will add 1, 1, 1. Here we are just going up, we are not going down. And in fourth step, 1 plus 1 plus 1 plus 1, and so on. So what is this? It's 1, 2, 3, 4, and so on. So this sequence is sequence of counting numbers. So you can say that this is sequence of counting numbers. So this is the first part of our question. That which sequence you will get when you add all one sequence up. Let's see the second part. What sequence do you get when you add all the ones, again one sequence, but this time it's up and down? So I'm writing again all one sequence for you here just for explanation. Now adding ones up and down. This time we'll do up and down. So just see here. In first step we'll just write 1. In second step, we have to go up 1 plus 1, and then we have to come back to 1. So that means 1 plus 1 plus 1. In third, first we'll go up 1 plus 1 plus 1, and then we come back 1 plus 1. Till third number you will go, and then you will write second number, first number. In fourth, you will write first number, second number, third number, fourth number. Then you will come back third number, second number, first number. 1 plus 1 plus 1 plus 1, that is adding up. Now down, plus 1 plus 1 plus 1, and so on. So if you will add, what you will get? 1, 3, 5, 7, 9, and so on. And this is a sequence of odd numbers. So here the answer is sequence of counting numbers and sequence of odd numbers. So hope so now you know the meaning of up and down. So I will mark to here. It's up, then down. In third step, up till third number and then down. Similarly here, fourth up, and then from fourth to one it's down. Okay, let's move to fourth question. Which sequence do you get when you start to add counting numbers up? And this time here you have to add counting numbers, but only up. So first you should know what is counting numbers. So I will write that for you. Counting numbers, that is 1, 2, 3, 4, 5, and so on. Now when you will add counting numbers up, when we add counting numbers up, what will get? That means first step you will write only 1. In second step you will add first and second. In third you will add first, second, and third. In fourth you will add first, second, third, fourth. In fifth step you will add first, second, third, fourth, fifth. So here no need to come down because it's just adding up. Now, just see what you will get. It's 1, then 3, then 6, then 10, then 15, and so on. Did you realize which sequence is this? Yes, it's a sequence of triangular numbers. While explaining triangular numbers, I told you that triangular numbers means adding counting numbers up. Sequence of triangular numbers. Now I will draw the pictorial representation on this side. So let's write the heading here, pictorial representation. So first is only 1, then 1 plus 2, then 1 plus 2 plus 3, then 1 plus 2 plus 3 plus 4. Here 1 plus 2 plus 3 plus 4 and plus 5, and so on. So this is the pictorial representation of triangular numbers. Here we are adding counting numbers. If you want to write, this is 1, here 1 and 2, 1 plus 2. This side 1, 2, and then 3. Here 1, 2, 3, then 4, and here 1, 2, 3, 4, and 5. If you count the total number of circles, it will give you 1, 3, 6, 10, and 15, and so on. Let's move to next question. Question number 5. What happens when you add up pairs of consecutive triangle numbers? This time you have to add up, but what? Pairs of consecutive triangular numbers. So first you should know what is triangular numbers. Even they have given you example, that is take 1 plus 3, then 3 plus 6, then 6 plus 10, then 10 plus 15. But what if they will not give you this example? So you should know that what is triangular numbers? It is as we just discussed, adding up counting numbers. That is 1, then you will add 2, you will get 3, then you will add 3, then you will add 4, then you will add 5, then you will add 6, and so on. So this is your counting numbers. So this time you have to add up just pairs. That means in first step you will add first pair, that is 1 plus 3, then 3 plus 6, then 6 plus 10, the next pair 10 plus 15, and so on. So that means I will rub this. That is just for explanation. I'm writing it again: 1, 3, 6, 10, 15, 21, and so on. So if you will adding consecutive pair of triangle numbers, what we'll get? We'll get 1 plus 3, then 3 plus 6, then 6 plus 10, then 10 plus 15, and then 15 plus 21, and so on. So which sequence will get? Let's add that: 4, 9, 16, 25, 36. Oh, what we get? We get sequence of, what is this? It's sequence of square numbers. As I told you, if you will skip first 1, 2 or 3 numbers in any sequence, it will not affect your sequence. Like here, we start from 2 square. We didn't wrote 1, but still it's a sequence of square numbers. But here we have to represent this with the help of picture 2. So let's draw its pictorial representation. That means you have to show that when you will add two consecutive triangular numbers, how you will get a square number. So let's draw that. First we have 4, so let's draw 4 circles. Then we have 9, then we have 16, 4 square, and then we have 25, and so on. Now we have to divide this square as sum of two consecutive triangular numbers. So here this is 1 plus 3, as you can see. Here 1, and the remaining one is 3. Here you can say 3 plus 6. Here you can say 6 plus 10. Here you can say 10 plus 15. So we have shown that how we can divide a square in sum of two consecutive triangular numbers. So this was 4, this was 9, then 16, then 25, and so on. These were the perfect squares. So let's move to next question. Question number 6. What happens when you start to add up? Just see here again, just add up powers of 2 starting with 1. That is, again they gave you example. First you should know what is powers of 2. Powers of 2. That is 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, and so on. Let's write it values. It's 1, 2, 4, 8. We have to simply multiply by 2, 16, and so on. Now they are saying that you have to add up powers of 2 starting with 1. So we know the meaning of add up. So let's write add up powers of 2 starting with 1. Till here you should know the meaning of add up. That means in first step we'll just write first number, that's 1. In second we'll add first 2, that is 1 plus 2. In third step we'll add first 3, that is 1 plus 2 plus 4. In next step we'll add first 4, that is 1 plus 2 plus 4 plus 8, because it just add up, so we'll not go back. Then first 5, 1 plus 2 plus 4 plus 8 plus 16, and so on. That's the meaning of add up. Now, after this, let's write the answer for this: 1, 3, 7, 15, and so on. You can write 31 if you want to write the next one. Now they are saying that you have to add 1 to each of these number. So we'll add 1 again. So right now, adding 1. we get, if you want to write one more number, I'm writing 31. So you will get 1 plus 1, that's 2, 3 plus 1, 4, 7 plus 1, 8, 15 plus 1, 16, 31 plus 1, 32, and so on. What is this? 2, 4, 8, 16, 32. This is nothing but 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5, and so on. Did you realize something? This is also powers of 2, but it increases by 1. Earlier, the powers of 2 was 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the 4. But now it's 2 raised to the power 1, 2, 3, 4, 5. That means power of 2 is increases by 1. But the sequence is same, power of 2. Let's move to next question. Question number 7. What happens when you multiply the triangular numbers by 6 and add 1? First, you should know what is triangular number. So let's try that. That is 1, 3, 6, 10, 15, 21, and so on. Basically, you have to add counting numbers up. Now they're saying multiply by 6. So first we'll multiply these numbers by 6 and then we add 1. Now we'll multiply by 6. So you will write, when we multiply by 6 and then add 1. You can even do that in same step and then add 1. We'll get, let's write that 1 into 6, but then you have to add 1. Next, 3 into 6, then you have to add 1. Next, 6 into 6, you have to add 1. That's why I'm putting bracket, because it's written first multiply 6 and then add 1. So we are following board mass. Then 10 into 6 plus 1. Then 15 into 6 plus 1. And so on, because for sequence we just need first 3 4 steps. Now 1 into 6, that is 6 plus 1. Let me write that step 2 for you. 18 plus 1, 36 plus 1, 60 plus 1, and 90 plus 1. Now what is this? 7, 19, 37, 61, 91. Which sequence is this? You know this sequence. When we add multiples of 6, when we add multiple of 6 here, it's 12, then plus 18, plus 24, plus 30. It's sequence of hexagonal numbers. But in this it's written, can you explain this with a picture? So we have to draw the picture too. So let's write pictorial representation. So for pictorial representation, we have to start from 7. We know that's the second step. So we'll write 2 plus 3, then plus 2. For third step, we have to start from 3. 1, 2, 3. Then we'll go 1, 2, 3, 4. 1, 2, 3, 4, 5. You have to go till 3 steps, then go back. 1, 2, 3, 4. 1, 2, 3. Now it's the fourth step, because we have started from 7. That's second step. So we have to start from 4. 1, 2, 3, 4. Then now we'll write till 4 steps. 1, 2, 3, 4, 5. The second step. 1, 2, 3, 4, 5, 6. Third step. 1, 2, 3, 4, 5, 6, 7. Fourth step done. Now we have to go back. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4. At 4 we have to stop, because we have started from 4, and so on. So you can write under that it's 7, 19, 37, and so on. So this is the pictorial representation of hexagonal numbers. Now, if you will observe carefully, you can divide these hexagons like 7, 19, 37 in this way, like 1 into 6 plus 1, 3 into 6 plus 1. So I will just show you one example, like how we can divide 19 in this way, 3 into 6 plus 1. Just see this carefully. Here we have 19 dots. This is this one. So we can divide this in 6 triangles, each having 3 dots. So you can say 3 into 6. And then we are left with 1 dot. Yes, so that's why we have represented 19 as 3 into 6 plus 1. Similarly, we can do for all. So let's move to question number 8. What happens when you start to add up? Just see the word carefully. Just add up, not down. Hexagonal numbers. Although they have given you hint, but let's try that. What is hexagonal numbers? When we start with 1 and when we add multiple of 6, like first you will add 6, then 12, then 18, and so on. So these are hexagonal numbers. Now you have to add up hexagonal numbers. So I'm writing add up hexagonal numbers. We get 1, then we'll add first 2, that is 1 plus 7, then we'll add first 3, that is 1 plus 7 plus 19, then we add first 4, 1 plus 7 plus 19 plus 37, and so on. So if you will add, what will get? 1, then 1 plus 7 is 8, then 1 plus 7 plus 19, that is 27, then 1 plus 7 plus 19 plus 37, that's 64, and so on. Now which sequence is this? Because they ask which sequence do you get? It's a sequence of cube numbers. Now these two figures are given in your question. Now they are saying, can you explain it using a picture of cube? If you will see cube carefully, this is your cube. Yes. If you will see this carefully, did you observe something? Yes, you observe hexagon in this cube. How? First, just see this figure. Just see the boundaries. What will get? It's hexagon. And if you will just select this as circle, yellow dot, and then these two lines, it's red one, see here, and then the other boxes as blue here. Now what is this? This is also hexagon. That means we can see that we have a hexagon in a cube and a cube in a hexagon. Yes. Now let's see the pictorial representation of cube. This is for 1, and if you'll see carefully, it look like hexagon. Then similarly we'll draw for 2. You have to draw one line like this, and then 3 and 4 is given. You have to draw properly with the help of ruler. Now you will draw 2 lines like this and 2 lines like this, 2 horizontal, 2 vertical. Then extend these lines like this, again 2, then 2, and then 2. So here it's 1 cube, then 2 cube, that's 8, 3 cube, that's 27, and 4 cube is here, 64. Yes, that's a pictorial representation of cube, and if you will see carefully, it looks like hexagon too. Now I will explain you this too, like you can say how 1 becomes 1 and 1 plus 7 becomes 8 in this figure. Just if you will just see yellow one, that means a single 1 cube and it looks like hexagon too. Now let's see 1 plus 7. So if you will see this one and then 7 means these 7s, these 7. And if you will combine this, what you will get, and how it's 7? 1, 2, 3, then this one 4, 5, 6, and 7 is under 2, that is not visible. So if you will add this 1 plus 7, what you will get? You will get 8, because this is also a perfect cube. And similarly for this, that is 27, and the full one will give you 64. Now let's move to last question. Question number 9. Find your own patterns or relations in and among the sequence in table 1. If you know table 1, where we have sequence of odd numbers, even numbers, square, cubes, power of 2, power of 3, Viranka numbers, triangular numbers. So you have to explain any one, and you have to explain why with the help of picture or otherwise. So I'm giving you one example. You know that square and the relation between squares and odd numbers, like one square is 1. Now 2 square, that is 4, and that sum of first two odd numbers. Then 3 square, 9, and that is sum of first three odd numbers. Then 4 square, that's 16, and that is sum of first four odd numbers. And 5 square, that is 25, sum of first five odd numbers. So here they say that relation, so that's a sequence of odd numbers and that's a sequence of squares. So you can write that every square, and you can write and so on. Dot every square, in square you can say, can be written as sum of first in odd numbers, sum of first in odd consecutive numbers. Yes, now let's see the pictorial representation of this that we've already discussed. So I will not draw that, but I will show you that once again. So pictorial representation, the first slide here. Here we have discussed this. You can see the first one. So here the pictorial representation I have shown you for 6 square. Similarly, you can do for 1, 4, 9, 16 and 25. So that's all for today. We will continue this chapter in next video. So stay tuned and keep learning with me. If you enjoyed this video, don't forget to like, share and subscribe to my channel Mathify with Meenakshi. Thank you everyone.